So this is an explanation of how to do the capillary NMR with manual injection, which you can use any solvent and you can recover your sample, unlike with the automation system. So the first step is to make sure that the automation is not running. To come to the screen of the automation system and check on this part right here. If they're all red or bluish purple, they're not running. If there's anything that's green, yellow, or bright purple, something may be running, and you should make sure that everything is stopped before you go to the next step. In this case, everything's fine, nothing's running. So then we can get the kit for manual injection, which is down here. And we're going to take it over to the magnet and begin setting up for manual injection. Okay, so now we come over to the system and we're going to set up. The first thing is to put this bowl under here to collect any of the solvent that drips down as we're flushing various things out of the system. And then we're going to disconnect the lines from the automation. So this black line is the input from the automation system and this purple line is the outlet. And then it goes in to the probe, up to the coil, and then back down and out. So we're going to disconnect both sides of it. So just unscrew it and try not to jostle the probe too much as you unscrew it. And you can just set these aside. And they may sort of twist around on you, that's okay. Okay, so next we're going to connect the lines needed for manual injection. So on the outlet, we're going to connect this line that is symmetrical on both sides. So both connections have the angled fitting on the end. So it's the same on both sides and doesn't really matter which way you connect it. And we're going to put that on the outlet. And it doesn't really matter which one we use for the inlet and the outlet on the probe, but typically we use the close one for the inlet and the far one for the outlet. So I'm going to screw this line that's symmetrical on both sides onto the probe. And then I'm going to attach this next line here. This one looks almost like the other one, except that one side has the angled connection and the other side has a flat fitting on it. The reason for this flat fitting is that it is going to attach to the filter. So this white piece here is the filter, and inside there is a stainless steel filter with a little Teflon gasket. We're going to put the Teflon gasket up against the flat end here and tighten it down. So this is a filter on the inlet, and then this part is going to attach to the input of the probe. The advantage of this filter, in addition to allowing us to make sure that the probe doesn't get clogged, is it allows us to put a few different fittings on the end here. So the first fitting we're going to use is this one that goes from a flat connection to a lure lock connection, like on a syringe. And this is what we're going to use to push the solvent out of the probe with air. So I'm going to tighten this down. All of these connections should be finger tight. Don't tighten them as tight as you possibly can, but they need to be tight enough that they're not going to leak. Okay, so we have the outlet line and that's symmetrical on both sides, and then this long line that has a angled connection and a flat connection goes to the filter, and then the filter goes to this adapter, which finally goes to the lure lock connection, which is used for a syringe. So the first syringe we're going to put on there is this big one, this 10 milliliter syringe. This one we're just going to use to push out any solvent that's in there with air. When you're using this one, make sure never to draw it up while it's attached to the system, because we don't want to suck solvent back into the syringe. We want to keep the syringe as clean as possible. And this kind of funny thing on the end here is to allow us to push it down and lock it into place, because when we push in the air, it's going to build a lot of pressure, but we'd have to hold it in for a long time in order to push all the solvent out. So this will allow us to lock it into place, and then we don't have to hold it. Okay, so I'm going to draw it up to 10 milliliters. I'm going to tighten it down onto the connection, and I'm going to push it in. It may have a fair bit of back pressure as you get near the end. It's okay. And go ahead and lock it into place. And now we're going to watch on the other side to watch the solvent come out. it takes a while for the solvent to come out. And what you should see is initially a bubble starts to form on the outlet of the line here. That bubble will grow larger and larger as the air slowly pushes it out. Remember that the lines are very, very small in diameter. This is why we need to always have our samples filtered, because it can easily clog the lines. The reason they're so small is that we want all of our sample to be up in the coil and not waste very much sample on the way out. What we're watching for here is what it just did, where air starts coming out. So it's pushed all of the liquid out, and then it sort of spits out the remaining bits of liquid as the air is coming out. So now the probe is completely empty. It's just got air in it. So we can go to the next step, which is to wash the probe out. And typically what we use to wash the probe out is acetone. Acetone is miscible with most solvents, and it dissolves a lot of different materials, so it's a good option to clean out and make sure that the probe is free of any contamination that might have built up in there from previous users. So we're going to use this 250 microliter syringe to flush out the probe with acetone. And we typically use deuterated acetone just because it's convenient and relatively clean compared to lab grade acetone. So I'm going to put on some gloves here. And I am going to draw up some deuterated acetone. Fill the syringe. Doesn't really matter if there's a small air bubble at this point. Later on, it is important to worry about air bubbles, but for now, if there's an air bubble, it won't affect the cleaning of the probe. So now I'm going to attach this syringe onto the lure lock connection, and I'm going to push the acetone through the probe. Now there may be a fair bit of back pressure as you push it through. That's normal. Just be aware that if you push really hard, you have the ability to create quite a bit of pressure. You have quite a bit of mechanical advantage here. So what you want to do is push it through so that the acetone comes through at a reasonable rate. You don't want to push it so hard that it starts leaking. If it suddenly gets much easier to push, then you've probably developed a leak, and hopefully that is not inside the probe. Yeah, just keep steady pressure on it and push the acetone through. It will take a while to flush out the system with acetone. So now we've flushed acetone through the probe, and we can go back and flush out the acetone with air. So we're doing air, acetone, air. So I'm going to attach the big syringe again. Make sure, remember to draw it up before you attach it. And then I'm going to push it down and lock it into place. And we're going to watch the acetone come out. There you can see the bubble starting to form, and it will slowly push its way through the probe. You need to wait until the air has pushed the acetone completely out of the probe, and you can tell because the bubbles stop growing on there and air starts flowing out of the end of the capillary. So we're getting there. Okay, that's it. The air has pushed out the acetone. So now the probe is empty again. Now, it's not strictly necessary, but it's often a good idea to then flush the probe again with whatever solvent that you're using. In this case, we're using chloroform, so I'm going to do a flush with chloroform. So bring your solvent, and as long as your solvent is clean, you can use a syringe. Draw up another 250 microliters of your solvent. Attach it on. And flush it through the system. Different solvents have different viscosities. Acetone has relatively low viscosity, so the back pressure will be less on it. The chloroform's got a little bit higher viscosity, so it will have a little bit higher back pressure on it as you push it through. It's going through fairly nicely though. If anytime you're flushing the solvent through, it feels like you just can't push it through, then you've probably developed a clog. The clog may be in the filter, hopefully, or in the line, but it's a good idea at that point to contact the staff and we will try to diagnose what the clog is. This is why it's very important to always filter your samples prior to loading them, because we don't want to ever clog the probe. In this case, things are flowing well, so we're going ahead and finishing out the flush with chloroform. Now, it may not be obvious, but it's a good idea to push the chloroform out again with air before we actually load our sample. The reason is we don't want to dilute whatever sample is in there, so if the probe is full of chloroform, it may dilute the sample somewhat. So I'm going to go ahead and use air again and push out the chloroform that I just flushed through the probe. And after this, we know that the probe will be pretty clean. So once again, going to wait for the solvent to come out and watch the bubble form on the end of the capillary and wait until the air is pushing it out and there's just air flowing through the capillary. If you hear the lock beeping as this happens, that's a good sign, because that means that you've actually pushed the solvent out of the probe and now the probe has no lock solvent in it and there's nothing for it to lock on, so the lock will beep. That means that it's working and that you're pushing out the solvent. Okay. If you want, like I said, you could do it a second time. You could disconnect the syringe, fill it again, reconnect it, make sure all your fittings are tight, and then pressurize it and lock it into place and flush things through. I'm pretty sure it's pretty well flushed by now. So now the probe is empty and it's ready for us to load our sample. So to load our sample, we're going to take off the syringe and we're going to take off this adapter that goes from the filter to lure lock. And we're going to put on a piece that will allow us to load a very small syringe. So this has this green plastic tubing here that a 50 microliter syringe can fit into, and it's going to attach onto the filter. This green part is replaceable, so you can put in a new one. You do want to make sure that it's clean. Likewise, you want to make sure that your syringe is clean before you load your sample. The tip of the syringe and the inlet are probably the most likely causes of contamination from carryover from one person to the other. So you want to make sure all these pieces are clean before you load your sample into the probe. In this case, I'm fairly confident that they're clean, so I'm going to go ahead and load our sample. I have a sample here in a vial. Remember that when you're preparing a sample that it needs to be filtered just like it would for the automation system. You can use the centrifuge filtration method if you prefer. If you have filtered it for HPLC, that's probably sufficient. But just remember that if you've concentrated it down, there's a possibility that it is precipitating, and that even though it's clean, if it's precipitating, that could clog the probe. So we want to make sure that there's no particulates in the sample at all, even ones that you can't see. Just because it's clear to the eye doesn't mean that it's clean enough for the probe. It could still contaminate or clog the probe. So this sample has been filtered. I'm going to go ahead and load it in. If you have an extra sample, you can draw it up, but you need to draw up at least 25 microliters of sample. If you have an air bubble, you need to make sure it's at the top, and if you can, you want to try to get rid of it as much as possible. In the cleaning stage, it wasn't really a problem if there's an air bubble, but in here, if there's a bubble in the middle of your column of sample, that's going to go into the probe and put a bubble into the coil, and that's going to screw up your shimming. So we want to make sure it's free of air bubbles, and again, you want at least 25 microliters of sample. Okay, so now what we're going to do is we're going to put the syringe into the inlet here. You want to push it down until it hits the bottom, and then carefully you want to tighten it. Tightening this connection here will make it so the syringe is sealed, and so when you push in the sample it doesn't come back out. That would be bad. So now we're going to push the sample into the probe, and if you have 25 microliters, that should be enough to fill the probe but not exit out of the this outlet here. If you want to be extra careful to recover your sample, you can put a recovery vial on here at this point. In this case, I'm not too worried about it, so we don't need to do that. So I'm just going to carefully, slowly push the sample into the probe. And if all goes well, we will have filled the probe. And this little piece of tape here is so that we can just keep the syringe there while we run. So you can just put it like that. And as surprising as it is, your sample can evaporate back through the line. So if you're running for an extended period of time, it's good to put a cap. I've made a cap out of a plug and a union here onto the outlet. Okay, so now the sample is loaded into the probe and we're ready to go. Okay, now that we've loaded the sample into the probe, we can use Icon NMR to run the experiment just like you would on any of the other Brooker NMR systems. And I'm going to show you how to use the automation system just like we often do with the other systems. So click on automation and log in with your username and password. And you can add an experiment to holder 1. You'll see that the experiments are all the CAP NMR experiments, so you can do proton, COSY, HSQC, NOSY. I don't recommend a carbon, but if you really want to, you can do a carbon. We're going to do a proton here. We should choose the solvent, so we've got chloroform. And you can customize the parameters if you want, just like on a normal system, and put in a title. Okay, next we can submit the experiment and go run, new run, and I'm going to choose the manual lock and shim and click start. Now we've already loaded the sample into the system manually, but because we're using the automation, it thinks that we need to eject and insert the sample. Just don't worry about it. You can just click OK each time. It won't know the difference. So it thinks that we're ejecting the sample, but we're not. And now it thinks we're inserting the sample, but we're not. So then the next step is to lock. Now the lock signal on the capillary NMR is weaker than it is on the normal because we have so much less solvent. So after you lock, it is, and this may be, you may see this, it just means that it didn't load the standard shims. That's okay. So we can do automatic lock, and it should lock in the normal way. But if the signal is noisier than you're used to, don't worry about it too much. Or if it's really noisy, then that can be an indication that there's a problem with your sample. Either there's an air bubble in the way or something is wrong. This is reasonable for chloroform on this probe, this amount of noise. Okay, now for shimming, I'm not going to cover that right now, but shimming on the capillary NMR probe is very different than it is on a normal NMR probe, because the capillary is oriented perpendicular to the field, whereas a normal NMR tube is parallel to the field. So the main shims that you would use would be y, z squared, x squared minus y squared, xy, and to a lesser degree x and z. So shimming with your normal z and z squared will not improve the shims. Probably the best thing to do is to click RSH and load in the Cap NMR shim with the solvent that you're using. And if you want to try to improve it beyond that, you can read the guide on how to shim on the capillary NMR system. In this case, I think the shims are okay, so I'm just going to click shim OK. And then come back to the automation system. It's doing the receiver gain adjustment like normal, and then it's going to go in and start collecting data like normal. Just like on a normal system, if you want to, you can click on spectrum after it's started to look at a snapshot of the spectrum while it's underway. So I will go ahead and do that. And it should bring up the spectrum as it normally is. You should be able to get a data set that looks reasonable. The line width might be a little bit broader depending on your shimming than it is on a normal NMR probe, but you should be able to get under 2 Hertz line width. And remember that the capillary NMR probe is less sensitive than a normal probe on a concentration basis, but the volume is much, much less than it is on a normal NMR probe, which gives you the advantage in signal for the total amount of sample. But remember that your concentration needs to be at least as high and probably twice as high as you would use on a normal NMR probe for the same amount of signal averaging. Once the spectrum is finished collecting, and then it's going to tell you to eject the sample, but again, you can just ignore that. And then when you're done, you can stop the run. Yes, you really want to stop. And then you can close this to make it ready for the next person. You can say no. So now it's ready, and your data should be collected just like it is on a normal system. So it should be under your username. And you should be able to double click on it and see the data that you've collected. Okay, so we're done here. So the last thing to do is to remove your sample and get the system ready for automation again. Okay, now we're going to try to recover our sample. So I'm going to take off this union. If you want, you can try to wash out anything if it has come out of here so that you don't lose any of the material that might have touched the union. In this case, I'm just going to put the inlet into a vial. I'm going to get the syringe out, loosen it, and I'm going to draw it up with some clean solvent. And you'll want to probably draw up more than the 25 microliters you used before. I'm drawing about 50 microliters here. Put it in and go ahead and push it through. And if all goes well, you should see a bubble forming on the outlet. So now we've recovered our sample. It's a good idea to flush out the solvent that's remaining in the probe. If you want to, you can flush this into your vial just to make sure you've captured the last remaining bits of whatever's in there. So I'm going to reattach the adapter that goes to a lure lock. going to reattach the large syringe. And lock it in place and push out the remaining solvent. Now that we're done, going to set aside my sample and disconnect the lines from the probe. So disconnect the adapter, put that back in the box, disconnect the inlet and the outlet lines. These should be clean because we flushed them through. If you did not flush them through, please clean them prior to putting them away. And then we want to reconnect the automation inlet line. Again, these just need to be finger tight. There we go. And the waste line. Last step, after putting away all your materials, is to flush out the lines from using the automation system to make sure that everything is ready to go for the automation system. So we will go back there and I'll show you how to do that. Okay, now that we've reconnected the automation system, we need to get it ready for use of the automation system. And the main thing we need to do is flush out the lines using the syringe pump in the automation system with chloroform, or the solvent that's loaded in the automation system. To do that, you can come to the screen here and go to the Run Process window. If this isn't running, you can restart it here with this one Start First Run Process icon, but it should be running already. And then we can go to Pumps, and the HTSL CDCL3 is the option that we want to choose here, and this will open up direct control over the syringe pump. So what we want to do is flush the syringe pump. This will cause the syringe pump to empty and then refill. Down here, this is a little graphical depiction of the syringe pump. So right now the syringe pump is full of solvent, and as we flush it, it will slowly move this way, dispensing the solvent into the probe. When it gets to the end, then it will refill from the solvent reservoir until it's full again. So I'm going to press flush, and we can see now that it's flushing, and it will empty out. Now it takes quite a while for this to happen, so I am going to wait for it to happen and come back after it's finished. Okay, now that we've waited, the indicator went all the way to empty and then refilled, and it's almost to the end of filling. So we will wait for it to finish filling here. That means that the syringe has refilled with solvent from the reservoir down here. One thing you can check to make sure is that there actually is solvent in the reservoir. For chloroform, we're using reservoir C. If the solvent is very low or empty, please let me know. In this case, it's fine. So we come back up here, and now it says ready, so it's been refilled. You can close this direct control window, but you should leave this Run Process window open. If you close that, it will lose communication with the automation system. So leave that open, just minimize it. And then make sure that the solvent conditioner is running. That puts a blanket of nitrogen over the solvent, so that should be running in the background. And then the web page should be available here for somebody to log in. Now it's ready to go, and the next person can use it for automation.